Hello and welcome to this webinar. In this session, I will highlight some advanced features that we have recently released. These features might have slipped under your radar, but could be highly beneficial for your upcoming design or transition projects. My name is Slaven Rumenjak, and I am Solution Architect within the Network Business Engine at ALE. The first feature we will talk today is dynamic link aggregation over shortest path bridging networks. In this session, we are setting up a dynamic link aggregation group between two far-end devices, which are either connected or separated depending on your preference by an entire SPB or shortest path bridging network. This feature is available starting from 8.10 R1 release and is supported on all devices that are compatible with the SPB protocol, with no restrictions on specific product lines or models. The primary goal of this development is to enhance throughput between two end devices, which could be located in geographically separated data centers, while also providing increased resiliency in case of a failure. In AOS, Alcatel operating system, there are two primary types of SPB services, ELAN and ELINE, each with distinct characteristics. The ELAN service is designed for multipoint to multipoint connectivity, where a full mesh of connectivity is established between all nodes or backbone edge bridges, on which the same service, identified with ISIT, is deployed. Each BEB can host one or more service access points or subs. This service allows for the seamless transfer of data across all connected nodes, making it ideal for scenarios where multiple locations need to communicate with each other. The ELINE service, on the other hand, is used for point-to-point connectivity, linking only two subs, whether they are on the same BEB or across different BEB nodes. When configuring an ELINE service in AOS, a pseudo-wire parameter is specified, which defines the point-to-point nature of the service. This service ensures direct communication between the two endpoints. Also, in ELINE, there is no flooding or replication of packets as there is in ELAN. Additionally, there is no MAC learning on subs in an ELINE service. When configuring port as a service access port, an L2 profile is automatically applied to that port. This profile determines how control frames such as STP, LSCP, 802.1x, and others ingressing the sub are processed. As shown in this slide, there are three options for processing these control frames. Dropping the control frames coming from the switch or customer premises equipment, CPE, are dropped. Establishing peering between the switch and BEB nodes on which the sub is created, or tunneling control frames through the SPB service. In addition to the default behavior defined by the default service L2 profile, AOS allows for the creation of customized profiles. These custom profiles can modify the default behavior to better meet specific customer requirements. Once a new profile is created, it is crucial to apply it to the specific service access port of interest. If this step is overlooked, the default profile with its associated behavior will remain in effect. The slide also provides details and CLI commands necessary to create a new profile and apply it to the required service access port. Since we are discussing the LSCP protocol, let's quickly recap what LSCP is. According to the IEEE 802.3 AD standard, link aggregation allows one or more physical links to be aggregated to form a link aggregation group, which can be treated as if it were a single link. In AOS, this is referred to as a logical link. The purpose of LAG is to increase bandwidth and enhance link availability between nodes where the two ends of the LAG are established. LSCP provides a dynamic form of link aggregation and uses link aggregation control protocol data units, which are sent and received by switch on both sides of the link. These LSCP DUs are used to monitor and maintain the dynamic aggregation group. it is crucial for both ends of a dynamic leg to be able to send and receive LSCP DUs to ensure proper operation. For more detailed information on LSCP configuration and behavior, please refer to the OmniSwitch Network Configuration Guide. However, as highlighted, for a dynamic lag to function correctly, it is essential that both ends can communicate via LSCP DUs. How can you establish dynamic link aggregation between two devices that are not directly connected, but are instead connected to different sides of an SPB network? This is possible starting with 8.10 R1 release, and the following steps need to be followed for it to function properly. The first step is to create a custom service L2 profile to modify the default behavior for LSCP packets. In the default profile, LSCP packets are allowed to establish a dynamic lag between peers. However, a new option has been introduced, allowing LSCP packets to be tunneled through the network. This is done by using the tunnel option when specifying behavior for 802.3 AD frames, as you can see in this example when creating a new profile called L2P. Once created, this profile must be applied to the service access port of BEB nodes to which any of the links used in the LSCP are connected. After enabling the tunneling of LSCP packets on the service access ports, we need to create a tunnel between the two endpoints. This tunnel will facilitate the exchange of LSCP packets as well as control and data plane packets from other protocols. The tunnel will use an E-line SPB service with the pseudo-wire parameter. As you may recall, this service has only two subs, with each sub created on the service access port of two BEBs to which the physical links participating in the dynamic lag are connected. It's crucial to replicate this configuration for each pair of physical links from the CPEs that are part of the LSCP group. A prime use case for this feature comes from one of our customers' networks, in which a pair of separate links were used for DC to DC communication, both of which are connected through the main campus. For redundancy, each data center is linked by two long-distance fiber connections, with PVST Plus protocol used for loop prevention. However, this design has notable drawbacks. Most significantly, spanning tree protocol disables certain links, rendering them unavailable for traffic, which reduces the overall network efficiency. The new design, which integrates SPB within both the campus and data centers, effectively makes the backbone transparent to the data center sites for DC to DC traffic. From the perspective of the data center, connectivity is established through link aggregation groups, eliminating the need for spanning tree. This ensures that no links are disabled, allowing load balancing across all available connections. Additionally, MACsec tunneling through the SPB pseudo-wire service ensures secure end-to-end communication. This slide provides a complete configuration for establishing dynamic lag through the SPB network. Let me highlight some critical details necessary for the correct setup. A new service L2 profile is created to modify the default behavior of the 802.3 AD protocol from peer to tunnel. This change ensures that LSCP packets are tunneled through the SPB network, enabling dynamic lag across the BEB nodes. This configuration is identical across all BEB nodes, as the same role is applied to their respective service access ports. In addition to the new profile, the slide also shows you pseudo-wire services are created on each BEB node. It is crucial to ensure that ISITs and BVLANs are consistent across the network for each service. For example, the top service has an ISIT of 1000 and uses BVLAN 4002. The bottom service has an ISIT of 2000 and also uses backbone VLAN 4002. Finally, subs, service access points, are created on the same ports where the new profile was applied. The encapsulation type is set to all, ensuring that the sub is configured correctly for the dynamic lag service. More than 2 links per single BB are also supported. In this slide, you can see the configuration details for such a use case. When utilizing this feature, there are several important rules of engagement that must be followed to ensure proper functionality. While I have touched on some of these already, let me list them all clearly here. You can choose only one LSCP mode for a given service access port, either peer or tunneling. You cannot run both modes on the same service access port. It is strongly recommended to configure pseudo-wire service for LSCP when designing a network with SPB. This is the preferred service type for ensuring smooth dynamic link aggregation through the SPB network. The SAP used for end-to-end tunneling should have an encapsulation all configuration. This ensures that all traffic between the two end nodes is transmitted through the links that form part of the LSCP group. The number of lag ports links can be dynamically increased or decreased as needed. As seen in the examples, you can use 2, 4, or more links without limitations from a software perspective. With these key points on configuring LSCP over SPB networks, we conclude this section and will now move on to the next feature, which is hybrid access port. The hybrid access port is a new feature that enhances flexibility of deployment by enabling the coexistence of SPB service domains and VLAN or bridge domains within a single hybrid environment. This feature became available with 8.9 R3 release and is supported on all products that utilize SPB technology. In AOS, users can choose between 2 port types, bridge and access. The bridge port type is the default, commonly used option based on VLAN domains, where functions like flooding, learning, and protocols such as spanning tree operate within VLANs. As a result, these processes typically function per VLAN or per bridge domain. With the introduction of various services in AOS, a service framework was introduced, which applies the same concept across different services. Part of this framework is the introduction of an access port type alongside the bridge port type. When using the access port type, VLAN domains are replaced by service domains. Customer traffic is assigned to a configured service instance through service access points or SAPs. Now, processes like bridging and flooding occur per service and SAP rather than per VLAN. Before the introduction of the hybrid access port, network administrators had to configure a port either as a bridge or access type. This created a clear separation, as a single port could only function in either a VLAN domain or a service domain. Once customer traffic was classified into one of these domains, AOS could handle both types of traffic over a single network port. However, the classification of customer traffic into either a VLAN domain or a service domain had to be done on separate ports. To enhance the flexibility of AOS, starting with 8.9 R3 release, we introduced the hybrid access port feature. This functionality allows a single port to accept and handle customer traffic in both VLAN and service domains. As shown in the diagram, this feature is especially useful when a switch or CPE device is connected to a BEB or backbone edge bridge node. In scenarios where the switch is linked to a BEB via a single logical link, which could consist of one or more physical links bundled in a line group, ingress traffic can be classified into VLAN and service domains based on the customer's VLAN's IDs. This feature is easily configurable using the familiar CLI commands for access port types, with new options to enable or disable the hybrid port functionality. When enabled, the hybrid access port has a default VLAN, set to 1 by default, but configurable by the administrator, and can support multiple VLAN domains as well as multiple subs, which serves as entry points to service domains. When using the hybrid access port feature, it is important to follow a few key guidelines. When configuring service access points on hybrid access ports, only single and double Q tags encapsulation is allowed. The use of null or all encapsulation is not permitted. As mentioned earlier, each hybrid access port has a default VLAN assigned, which belongs to the VLAN domain. On a single hybrid access port, VLAN IDs used for the VLAN domain and those used for the service domains must be mutually exclusive. This means that the same VLAN ID cannot be configured for both the VLAN and service domains on the same hybrid port. Additionally, if VLAN translation is being used with an SPB service, ensure that translated VLANs do not overlap with the VLANs used for the VLAN domain. It is also important to note that when the hybrid access port functionality is enabled, the default VLAN on that port will automatically be set to VLAN 1. This setting can be modified by the administrator later. When hybrid access port functionality is disabled, the default VLAN on that port will change to 4095, the standard value when configuring a service port from a bridge port. What is use case for the hybrid access port feature and how can it benefit our customers? A key use case for the hybrid access port feature is during network upgrades where customers are transitioning from a VLAN domain to a service domain. This transition enables them to take advantage of the advanced features that service-based networks offer. Before the introduction of the hybrid access port, this transition required two physical ports, one to connect clients in the VLAN domain via bridge port and another for the service domain via an access port. If only one link was available at first, this process would require physical access to each BEB to establish a second connection involving additional cables and transceivers. In cases where there were no extra physical ports, the transition could demand the use of additional switches, increasing both the complexity and cost of the upgrade. With the support of hybrid access port, no extra physical hardware is needed. The transition can be completed seamlessly using existing infrastructure, saving time and effort for network administrators and ensuring minimal disruption for network users. This brings us to the end of today's webinar, where we highlighted some of the advanced new features in the latest AOS releases. Thank you all for watching, and please don't hesitate to reach out if you have any questions. Have a great day.